Welcome to another session on Statistics Made Easy. I'm Marvin Hanisch, and in this session we're diving into data preparation. But before we get started, let's do a quick recap. In our last video, we talked about do files in Stata. Just to refresh your memory, a do file is like a diary of all the commands you're using. The advantage, you can reproduce your results and even share your analyses with colleagues. To create a new do file, we click on the pen and paper symbol here in the menu bar. And from this new window that is now opening, I can also select an existing do file. I click on the yellow map and select the data preparation do file that I've created in advance of this session. Remember, you can download all the files that I'm using in this tutorial by clicking on the download link in the video description below. The first thing you will notice is that Stata uses different colors in this do file: green, blue, black, and red. Green refers to annotations. These are really useful if you want to keep track of all the steps you have taken and potentially share your code with others so that they understand what you're doing. You can create an annotation by starting the code line with an asterisk or using 2 forward slashes. Blue refers to commands like clear, set, cd, or import. They're usually followed by specifications, such as I want to import an Excel file, or I want to browse certain variables here. These are in black. And red is used for either directories, file names, or labels of variables. Now, let's walk through this code step by step to see what is actually happening here. You can run code in Stata by first highlighting the relevant code lines with your mouse. I click on the row numbers here on the left and drag my mouse down. And now I can either click on the execute button on the right of the menu bar, execute selection, or, which is a little quicker, hit the Control D keys on my keyboard, and that will also run these codes. The first 2 lines of code, first of all, clear Stata's memory. In case there's any data loaded already, it will be overwritten and the memory emptied. Set more off refers to, or tells Stata that none of the output should be suppressed, and I want to see the full output. Typically, the first step you're interested in when you do analysis is to load a data set into Stata. I've prepared a file for this session, an Excel spreadsheet, which contains information about ice cream sales in a city. The ice cream parlor has 3 locations: the city center, the park, and the train station. In addition, we have a unique customer ID. We have a binary indicator for whether the customer is a child, where 1 is yes, it is a child, and 0, no, it is an adult. We have the income of our customers. Also note we have some NA values, which mean that the values are not available. We have a temperature column. We have the number of ice cream sold, and we have the purchase date. Now with this data, we first want to add this data to our Stata memory. For this purpose, I first tell Stata where the file is located. I use the command cd, which stands for change directory, followed by the location on my machine. You can find this directory through your Windows browser, or you can also use the Mac Finder to get this file location. Next, I use the import command and the Excel function to then load the data set into Stata's memory. You see that the file name here is put in inverted commas and followed by an option. This option here, first row, overrides the default settings in the command. In this specific case, I use the first row option to tell Stata that the first row in my data does not contain values, but just the variable names. And the sheet option tells Stata which of the maps or sheets in Excel I should use. In my case, the sheet is called ice cream. If I run these 2 lines of command, the cd command and the import Excel command, Stata now loads this data set into its memory, and I see that we have 7 variables and 123 observations. Next, I may want to inspect the data and just look at it, and this can be done using the browse command. Running this code will open a new window, as you can see here, and this browse window with the data editor now looks very similar to my previous Excel spreadsheet. So I can see the location, the customers, child, all the variables. And again, you will notice different colors. Red is used for string variables, which means any text in variables. And black is used for numerical values. This will become important in our next step when we try to transform some data. I can also display individual variables. For example, if I'm interested in only looking at ice cream, temperature, and child, I can specify this after the browse command. And if I run this code, I only get these 3 variables. Another way of adding or removing variables from this view is by clicking on the variables here on the right in this window. Another useful way to organize your data is the sort command. Sort will create an ascending order of the variables that you have specified. For example, if I sort temperature, the temperature variable will be sorted in ascending order with 0 at the beginning and 40 at the end, the highest value. I can also sort variables by categories. For example, I can first sort the data by child, and then within that category, sort the data by temperature. For example, if I run sort child temperature, I get all the children first in the data set, and then all the adults, and the temperature is ordered in ascending order here for each of those 2 categories. Another useful item or feature in Stata is that you can add labels to variables without changing the variable name. These labels are used when you output your data, for example, in the form of correlation matrices, regression tables, or graphics. The command starts with the label command, followed by the item I want to label, in this case, a variable, and then the variable name, in my case, temperature. After that, I specify the label I want to use. In this case, it's simply an uppercase temperature and in parentheses, the C for degrees Celsius. If I run this command and go back to my data editor, I see that now the variable has a label. It is temperature and then temperature parenthesis C in the second label column here. It doesn't change any of my actual data in this data editor. It only adds this label on top of the variable name. If I don't specify a label, the default label is the variable name. I can do that for all my variables, like label ice cream or label the income variable. If I do this, you will see that now Stata has overlaid these labels on these variable names. In addition to labeling a specific variable, like giving an uppercase to the variable name child, I can also label the items within each of these variables. For example, rather than using this 0, 1 indicator, I may want to add a label that specifies that 0 is an adult and 1 is a child. I start this command using the label command again, then I define a new label, that's why it's label define, followed by a label I choose. I chose simply child label. I can specify any name I want. And then I need to tell Stata how I want to label the value. 0, I say, is adult, and 1, the value 1, is a child. If I run this code, nothing really happens. Our children or our child column still is 0 and 1. Nothing has really changed. What is missing is that I need to tell Stata to now overlay these labels that I defined onto the variable child. I use this command here, label values child, that's the variable I want to label, and then followed by the label I just created, namely the child label. Running this code now overlays this label on this child variable. 0 for adults and 1 for children. And again, this can be useful if you want to output this data later on and you want to use these labels instead of a binary 0-1 classification. Similarly, you can also change a variable name if you want to. And this can be done relatively easily using the rename command. Rename followed by the old variable name and then the new variable name you want to use. For example, if I want to rename the customer ID to client number, I run this command, and you can see here also in my data browser that now my client number is the variable name, but it still retains the old label from the previous variable name, customer ID. If I want to change it, I can use again the label variable command to change that. One of the most frequently used and useful features in Stata is to create new variables, and that's what we're going to look at next. Let's say I'm interested in creating a categorical variable for temperature, which buckets temperature in 3 categories, like it is cold, agreeable, and hot. First of all, I create an empty column in Stata, and an empty column in Stata is represented by a dot. Dot means in Stata a missing value, or more specifically, it represents infinity. So if you sort your data and it has missing values, then the missing values will always be at the very end of the spreadsheet. I run this command. Generate is the command to create new variables. Then the name of my new variable, I call it temperature categorical, but you can again use any name you want. And what you will see now is that in my data editor, I have a new variable which only has missing values represented by these dots. So the full stop here represents this missing value. And I now want to add values to this variable. So I want to replace my missing values with some actual values. I use the replace command to achieve this. Replace values in my variable temperature categorical with 0 if the temperature is lower or equal to 15. So this refers to the existing variable temperature. Whenever this existing variable has a value lower or equal to 15, then I will create a 0 value in the temperature categorical variable. And you will see what happens. Now I have zeros whenever my temperature is equal or lower to 15 degrees, I'm sorry. And I can do the same for the middle bracket. Let's say my categorical variable takes the value of 1 if the temperature is between 15 and 25 degrees. And for all the values that are larger than 25, it will give a 2 in this categorical variable. And you see now I have created a categorical variable for temperature. And again, I can use the label commands we've seen before. I can label the new categorical variable with, again, temperature, let's say, and also add labels to each of the categories similar to our child variable. In this case, I use cold, agreeable, and hot as my 3 labels, and then overlay these labels on my existing temperature categorical variable. And you will see now in my data editor that I have now cold, agreeable, and hot weather in my data. In the same way that I created a variable, I can also delete variables using the command drop temperature categorical. I simply use drop followed by one or multiple variables that I want to delete. If I run this command, the data or the variable that I created is simply removed from the data set. But no worries, if you delete some columns in your data and you want to restore them, you can simply rerun the code here above and all the values will be reproduced and recreated. And then I can drop them again using the drop command. So that is a very handy feature in Stata, that you can simply go back a few lines of code and correct any issues that you have created in your data analysis. Another really important feature in data preparation is to work with text data. And as you see here in our data editor, we have a few text or string variables that we may want to transform into numerical variables. Why is this important? Whenever you use any form of numerical analysis, like a correlation analysis, or you want to do a regression analysis, you cannot work with text data. Instead, you need to convert those string variables into numerical variable first. There are different ways in which this can be done, and I want to show you a few possible options. The first option is the encode command. Encode basically creates an automatic categorical variable based on all the expressions of the data. It will use the numerical variable 1 for the first item that appears in the data set, and then for the second item it will use a 2, and so on. It will only consider unique strings. For example, in our case, in location, we have train station, city center, and park, the three expressions of location, and whichever comes first will get the value 1, the second will get this value 2, and the third will get the value 3. If I run this command, you see that now Stata has created a new variable in my data editor. It has the park, city center, and train station. The neat feature about this is that the actual values of this variable are unchanged. For example, park still has the park label here on top, but underlying this is a numerical value of 2. And for city center, it uses 1. So these are basically random assignments of these numbers, and train station gets the value of 3. An alternative way to convert these string variables into numerical variables is using the egen command. For example, here I use egen location number 2, which is the new variable name I'm creating, followed by the group function and then the variable name. In this case, Stata runs through the entire variable that we have here, location, and checks for all the groups that are within location, so the unique values here, and again, then assigns numerical values here. It functions very similar to the encode command, with the only difference being that it doesn't automatically overlay the labels that were previously the string items from the variable. So if I want to add park to the 2 and city center to the 1, I would have to do this again using the label variable command that we learned about earlier. A third option is to use the string functions in Stata. For example, what I do here is I create a new variable that is called city, and this city variable takes the value of 1 if in this variable location there is a string called city. I put that here in inverted commas. So whenever it contains these letters in this order, city, then it will create a variable that is 1 and 0 otherwise. In addition, I specified the lower option here, which tells Stata it should disregard upper and lower cases in this variable. And it will always use or find city even if it is spelled with a capital letter. So in this case, I now have a new variable that is 1 whenever the variable location contains the word city and 0 otherwise. And I can do the same for example, park. Then I get a binary indicator for whether the location variable contains the word park or train. As you can see, it finds the train station even when it is not exactly train, but is part of this string. So that can be another very useful trick to get to binary or categorical variables from string variables. Finally, I want to show you the dstring command. The dstring command removes any strings from an otherwise numerical variable. You may remember in our income variable, we usually have numerical values, except for a few cases where the data was not available, and we coded NA for not available. If I want to remove those NAs from my data and instead replace them with missing values, that is full stops in Stata language, I can use the dstring command. I type dstring followed by the variable name, in our case income, and create a new variable that is income num for income numerical or whatever name you want. And the force option tells Stata to execute this command even though the new variable will not be reversible and I can no longer add the NA back to that new variable. If I run this command, dstring, I create a new variable which only has numerical values, which you see also by the change in color. Now it's no longer red, but black, and Stata recognizes it as a numerical value. And the previous NA value has been replaced with a full stop, which is a missing value in Stata. And I can now use this variable, for example, in my correlation analysis or regression analysis. Another thing that you may be interested in is using the date and data time series functions in Stata. This is really important if you want to run a panel regression, for example, later on. But oftentimes when you open a data set, the date that you have in your data set is, for example, not in the right format, but instead it is a string variable, as it is the case here. So Stata doesn't recognize that as an actual date, but only sees it as a string. So first of all, we need to convert this purchase date into a new variable that is a date variable. Again, I use the generate command followed by a name that I want to give this new variable. I chose timestamp. And then the function date tells Stata that I want to convert an existing variable into a date variable. My old variable is called purchase date, and the option afterwards tells Stata in which format this string variable is. In my case, I have first the day, which is the capital D, then the month, the capital M, and then the year, the capital Y. Now Stata knows that I first have the day, then the month, then the year. They are separated by a full stop, but even if they were separated by, let's say, a forward slash or a dash, it would still work. I create this new variable, and this is now displayed at the end, and it doesn't look really satisfying. Actually, Stata uses an internal numbering for dates, and this is not really human readable. If I want to make that readable, I would have to overlay, again, a sort of label on top. And in Stata, we use the command format for this. So I format my new variable, which is called timestamp, with the time day values that are also present in my original variable. If I do this, I can now see that Stata uses the same format, but just the internal classification, like 7 November 2019, which is the same as my original string variable. And this is how we get from a string date to an actual date in Stata. And I can also use these date variables to extract certain time information. For example, if I want to create a new variable that is the year, I can extract the year from my time variable by using the generate command again, generate year, and extracting the year from my new timestamp variable. As you see in my data editor, I have now created this new variable year, which is simply the year that is already present in my timestamp. In the same way, I can do it for month, or I can also create a new variable that contains the month and the year using the year-month option in Stata. And again, what you will notice is that we are missing the format in this new year-month variable, which I can overlay using the format option again, and here the time-month specification. And we see here, now we have the proper layout, first the year and then the month. And finally, I may wish to add a label to my year-month variable, which you can then see in also my data editor, that this variable now has a proper label, month and year. Now let's turn to computing mean values by a group. For example, if you want to know the average consumption of ice cream by children, this can be achieved using the by command. By child, first of all, I say by which variable I want to compute the mean. It is by child, followed by the comma sort, which first of all sorts the data by children, as we've done before, and then theegen command, which you already know, which allows me to create variables that are referring to values across different rows or across different variables. Using the mean function, I can now create the average of ice cream consumption per category for adults and for children. Using this command creates a new variable, which is 20.76. That's the average consumption for children. If I look at my for adults, that's the first one. So 20.76 for adults, and for children, it is significantly higher, 30.25 for our children. So this is how you can create mean values by groups. Another useful transformation relates to, for example, natural logarithmic transformations. Log transformations are sometimes used if you have very extreme distributions that distort your values. For example, in the case of income here, I may have very low values, especially for children who don't have their own income, and very high values for certain adults. If I want to bring that distribution closer to each other and compress it a bit, I can use a log transformation. But note that whenever you do such transformation, you will actually also change the distribution and as a result, all the analyses and correlations that you get from it. If I want to do this, I can use the generate command again, and using the log function, followed in parentheses by my variable name. You notice perhaps that I'm adding a 1 plus to my variable name. This is because the 0 is not mathematically defined in a log function. By adding this 1 prior to applying the log transformation, I ensure that I don't get any errors when I compute this new variable. In my data editor, I now get this new variable, income log, which is the logged value of income. And you see that now extreme values at the lower and upper bound are kind of lower than in the original variables. Again, I can apply a label if I like, and move on to our next transformation, which is standardization. Standardization means that from a variable you subtract the mean value and divide that variable by its standard deviation. The result of this transformation is that the mean value will become 0 and the standard deviation will become a 1. Why would you do such a standardization of variables? This can be very helpful if you have different scales of variables. For example, income has a very different scale to, let's say, temperature. And if you want to compare the effects of temperature and income, and they are in different scales, you want to adjust the scales and make them all equal so that a 1 unit increase after standardization means a 1 standard deviation increase in that variable. And this way, the relative magnitude of a 1 unit increase in all the variables is comparable. And this you can find very often, for example, in regression analyses. If you want to compare different coefficients with each other, then standardizing the variables prior to that regression analysis can be helpful to make or ease those comparisons. Note also that standardization does not make sense for binary variable, for which a 1 unit increase always is a jump from 0 to 1. So you would only use it for continuous variables, and you would also not use it for any categorical variables. And now let's come to our final part of this data preparation, namely our first loop. Let's assume you don't want to label just a single variable using the egen command here and the standardizing of temperature that we can simply execute here. But I want to do that for a lot of variables. For this purpose, I can use a loop that goes through a set of variables. First of all, I need to define this variable list, and I can save this variable list in a macro. Here I use a global macro, which I call var list, followed in inverted commas by all the variable names: ice cream, income, and income log. All of these are the variables that I'm interested in standardizing. And now the loop function is as follows. For each element, which I call E, in my macro, which I reference by adding a $sign in front of the macro, which I call var list, do the following. And the following is here announced with this parenthesis, this opening parenthesis. Please use the egin command that we've already used before. Create a new variable that is called std underscore, and then the variable name in this macro, which is referenced with this E function here, and standardize that variable, which is also part of this variable list. So basically what I'm getting here is a standardization of all the variables that are here in this variable list. And the new variables that are being created will start with std underscore for standardized, and then the variable name. In addition, further below, you can also see that I'm adding a local macro. Local macros differ from global macros in that they will not be stored in the memory permanently. So once I've run the command, Stata will forget them, whereas a global macro will be remembered even after the code is finished. I use this local label macro here to store a local label of my original labels. For example, I've already labeled ice cream before and my income variable, and if I don't want to lose those labels from my previous variables, I will first store them in my memory and then reapply them to the new variables that I have created here. Label or store these previous labels in a local macro and then use those stored labels and apply them to my newly created standardized variable. If I run this code, I will get new variables that are now standardized, and they also retain the labels from my previous variables. So this is a very handy trick, especially if you want to standardize a large amount of variables at the same time. So this wraps it up. One question that I frequently get, if you want to log transform and standardize a variable at the same time, which one should you do first? Well, the answer is you would first do the log transformation and then the standardization. The standardization is always a linear transformation. It doesn't really change the distribution of the variables. It only will change, for example, the size of the coefficient in your regression, but not the significance of it. So first of all, if you want to do both, do first the log transformation and then the standardization. Now we've prepared our data set. All the variables we need are in the data set. I've added the labels, added my categorical variables. Everything is done. That only leaves us to save this data set using the save command and the name of the file that I want to use. In this case, I use ice cream data, followed by the format. I use the internal Stata format, the DTA format, which is something I would recommend because it retains all the labels, all the options you have specified, and it is also quite space efficient. Running this command will now save the data set in the directory you have specified in the very beginning. If you want to save it in a different folder, you can add the cd command before the save command and change the directory. That will then allow you to specify whichever directory you want for your final data set. Thank you very much for staying with me throughout this data preparation session, and I look forward to seeing you in our next session where we start analyzing data.